Alright, so you guys have learned two ways already to solve systems of equations. The first one is by graphing. In order to graph, we have to get both equations in what form?
Y equals mx plus
Good. Y equals mx plus b. What form is that called? Good. Slope-intercept form. The second way was substitution. So substitution is where you solve for one of the variables. It doesn't matter which one. And then you just plug it into the other equation and then solve and then plug everything back in and solve. Okay? Elimination, guys, guess what we're going to do? We're going to eliminate a variable. Okay? So another method for solving systems of equations is called elimination. And this is our third and final way. Okay? Now, like I said, because y'all were working on your checkpoint just a second ago, your test is going to assess you on all three ways. Okay? While all three ways get you to the same answer, if you do them correctly, we have to assess you on all three ways. You have to be able to do each and every one. So on your test, it's going to say solve by substitution. If you don't use substitution, you're not going to get credit. Okay? It might say solve by graphing. If you don't graph, you're not going to get credit. That's not to be mean, but we have to make sure that you can do all three ways. All right? Now, with elimination, the goal is to eliminate one of the variables so you can solve the equation for the other variable. Okay, so here are our steps here. Step one is going to be write the system so terms are aligned. So we're going to line up our x's, we're going to line up our y's, we're going to line up our constants. Okay, step two is going to be look for terms with opposite coefficients. What are the coefficients? Numbers in front of the variables. They have the variable. So if it has 3x, what's going to be the opposite of 3x? Negative 3x. Because what do you know about 3x's and negative 3x's? They cancel each other out. That eliminates it. Okay? Step 3, add the equations, eliminating one of the variables. So instead of plugging in, this time we're going to literally just add them. Okay? It's going to be like a giant addition problem. Then we're going to substitute, just like we did earlier, to find the final variable. So let's look at example 1. It makes more sense when we practice. It says use elimination to solve the systems of equations. Could we solve this by graphing?
Yes.
Could we solve it by substitution?
Yes.
Yes. In this case, though, elimination would be the best one because I have a negative 4x here and I have a positive 4x here. So we have two different systems, two different equations. But we already have opposite variables. So do you see how we have negative 4x over the 4x, and then the y's over the y's, the equal signs over the equal signs, the constants over the constants? Okay, our first thing we're going to want to do is line everything up if they're not already lined up. And we're going to look at which one has those opposite coefficients. So 3 and negative 5 are not opposites of each other. Okay, they're two different numbers, and one's positive, one negative, but they're still two different. 4 and 4, 4 and negative 4, these are opposites. So that's what we can get rid of. So we're essentially making a big addition problem. Okay? So we're going to do this equation plus this equation. Okay? We can only combine our like terms. What is negative 4x plus 4x? 0 x's. Okay? Which means there are no more x's there. We've eliminated a variable, okay? No more x's. Do we need to cross them out to make y'all feel better? What would y'all like to do? Okay, we can cross them out. Then I have a positive 3y minus 5y. What does that give us?
Negative 2y.
Good, negative 2y. Our equal signs drop down because they're aligned. Negative 3 and 5 gives us positive 2. So we have gotten rid of a variable. We have a single variable in our equation, so now we can solve for y. We can divide both sides by negative 2. So that gives us y is equal to negative 1. Good, yep. So once we've gotten one of our variables, then we're doing the same thing that we did with substitution, where we're going to plug it back in. It doesn't matter which of these equations you plug it back into. So which one would y'all like to use?
The top one.
The top one? Okay. So we can do negative 4x plus 3 times negative 1, because y is negative 1, is equal to negative 3. So we just have to plug. If y is equal to negative 1, we're plugging negative 1 in for y on either of these equations. Then we're just going to solve. Negative 4x minus 3 is equal to negative 3. So far, so good?
Yes.
Add 3 to both sides, so that gives us negative 4x is equal to what?
0.
0. And this is where you guys freak out, because you're like, oh my gosh, there's a 0 there.
Right.
Guys, negative 4 times what is 0?
0.
0. Negative 4 times 1 is 0. Very interesting. Didn't know that one. So x is equal to 0. Okay. And our final answer needs to be in what form?
Coordinate.
A coordinate. And every coordinate is in the form x comma y. We've got to watch out for that. So 0, negative 1. Good. So if we graphed these, where would these two lines cross?
0, negative 1.
A 0, negative 1. And that's going to be the solution that satisfies both of these equations. Okay. Questions?
It's not like you don't solve that.
Okay. So let's look at our practice problem. Do you guys want to go ahead and try on your own?
Yes.
Okay, y'all try the practice problem on your own. And then we'll go over it together in just a second. Alright guys, so when we used elimination to solve for this problem, we had negative 3x and a positive 3x. So when we added these, this got rid of our x's. 4y minus 6y gives us negative 2y, and 12 and 18 gives us 30. We divided by negative 2, so y is negative 15. Then we just plug it into one of these equations. I chose the second equation. So I did 3x minus 6 times negative 15 is equal to 18. And I got down to x is equal to negative 24. So negative 24, negative 15 is our solution. Raise your hand if you guys got that. Okay. How many of us, Jacob, did you at least get to negative 15? Okay. Did you plug it back into the first equation or second equation? The first equation. So if we use the first equation, that's negative 3x plus 4 times what? Okay, that would be y. That's perfect. Shefton, what did we do here to not get, did we not get 30? Did you subtract? Yeah, we got to make sure, since these are already opposites, we're adding them. Okay. All right, any other questions? Okay. Sometimes they're not going to be laid out perfectly for us. So I know y'all are like, oh, let's go to our homework now. Well, it's not always going to be that simple. Okay, so let's look at example 2. So example 2, we have 2x plus y is equal to 23. We have 3x plus 2y is equal to 37. I don't have opposite coefficients anywhere, which means we must make opposite coefficients. So you guys can tell me, would you rather eliminate x or would you rather eliminate y?
X.
Does it matter?
No.
No. Okay. In this case, do y'all see how we have 2x and 3x?
Yes.
What is the only number, what's the lowest number, their least common multiple? 6. So we would have to multiply both of these equations to get a 6x and a negative 6x. Whereas at y, we have a 2y and a 1y. So we could just multiply one of these equations to change it to what? A negative 2. Because we already have a positive 2, so we could just multiply this top equation to get a negative 2. I am all about multiplying once. Are y'all okay with that?
Yes.
Okay. So if I want to change this top equation, negative 2 or positive 2x plus y equals 23, I've got to change it to a negative 2y. So what do I have to multiply this whole thing by? Negative 2. Okay. Every single term has to be multiplied by negative 2. This is going back to some of those skills that we used when we had to rewrite in standard form. All right. So to rewrite this, negative 2 times 2x becomes negative 4x. Negative 2 times a positive 1y is a negative 2y is equal to what?
Negative 46.
Good. Negative 46. Everything has to be multiplied. Okay? Everything. All right. I'm going to go down here and I'm going to rewrite them and stack them. Okay. So it doesn't matter which one's on top. I'm just going to keep the negative 4x minus 2y is equal to negative 46. And I'm going to line that up with the second one. Positive 3x plus 2y is equal to a positive 37. Okay, now that we have opposite coefficients for y, what variable is going to disappear?
Y.
Y. Okay, so negative 2y, positive 2y gives us no more y's. Negative 4x and a 3x gives us how many x's?
X.
Careful.
1.
Careful. Negative 1x. And that's going to be equal to, what's negative 46 plus 37?
Negative 9.
Good. So negative 1x is equal to negative 9. Divide both sides by negative 1. So x is a positive 9. Are y'all okay with that? Huh? We got to plug it back in because we've got to find y. Again, it does not matter which equation you plug it back into. I always recommend one of the two original, not a rewritten one, because sometimes we make mistakes there. So I'm going to use the first one just because I only have to multiply the x's. So 2 times 9 plus y equals 23.